Yep. So if you see me putting a checkpoint in your test, means it's correct. If you see me putting a wrong in your test, means it is wrong. And if you see me putting a question mark in your test, means I don't know what you're doing, or in this case, wrong. Okay. So checkpoint in my test means wrong, correct. Cross means wrong. And I want you guys to check also at the corner here. I give you like a -2, or sometimes I give you a negative something, or so I give you a 0. That means this number on the side here is telling you how many wrongs you get here. So how many negative points you get. So I will total the negative point on the corner here. So, and then after that, I will add all these negative points on the corner here, and then I will subtract it from 60, because 60 is a total point. So make sure you guys got this meaning of this is how I grade your tests. We'll see all your tests here. So the first question in this case is a multiple choice. If you read this, the answer in this case is random sample. It's not clustered. It's not, the reason why it's not clustered is when you do clustered, you assign this and you only pick one group or two groups. This question is only assign these people randomly to 4 groups. So this is just a random sampling. So what is going on with the random sampling in this case is if you want to have clustered, yes, clustered, you assign them into 4 groups. And then you pick one group randomly. This is called clustered. This question did not mention anything about picking just one of this group, and you just only assign randomly. So that's the reason why that your answer in this case will be random. Okay, it's not stratified. It's because if it's stratified, then they will tell you how many people is selected from each group. Okay, so when you have stratified, you will break them into these 4 groups, and then you pick people out from here. So maybe 10 people from this group, 10 people from this group, 10 people from this group. This is called stratified. Okay, so in this case, your answer in this case is random selection for the first one. Question 2, is this statistically significant? So to answer yes, it is statistically significant. Your percentages has to, if you answer yes, your probability has to be less than or equals to 5%. But if you look at this, this is a 30% chance. This 30% chance is not bigger than 5%. So that's why your answer in this case, this is not statistically significant, because the chances of this happen, 30% is more than 5%. So make sure you guys understand, this is back on in chapter 1. Is this practical significance? Practical significance means you look at how is that practical. So based on the result show up 47 pounds is lost in after 12 months. So it's average 4 pounds a month. This is a lot here. So this is actually practical because you actually lose quite a lot of weight here. So it's considered practical. So this is how we answer significantly, statistically significant and practically significant. So one is using probability and one is using the result that is done by the survey. Question 4 is given us that this is the mean and the standard deviation, and we pick 100 people. So this is actually central limit theorem. Central limit theorem says that the mean is still the mean, 42, but the standard error in this case is the sigma over by root n. There are 16 standard deviation and there are 100, so your n is 100. So your answer in this case is 1.6. So it's 42 and 1.6. That is your answer for question 4. Anyone have any questions on the first page of your test?
So you said for number 2, if it's less than 50%.
5%.
I'm sorry, 5%. So 30% is more. So because of that.
So the answer is no. Yes.
Okay.
The answer is no.
I don't know. What was the clue? What was the hint to know that this was CLT? Because for some reason,
CLT is used when you have n, when n is given. Remember that in your chapter 6.1, 6.4, if you have n is 1, you don't use CLT. When n is like a lot, like 25, 30, 40, 100, we use central limit theorem.
Okay.
Next, this question 5, a lot of students make mistakes here is because they cannot convert 0.1% into decimals. So when I ask you to find the z-score of a bottom of 0.1%, that means your shading in this case is going to be on the left. 0.1% is 0.001. This is called a 0.1%. So when you put in your normal calculators, you have to use your normal calculators, you have to leave this blank and you have to use the less than or equal to because it's a bottom, and you have to put a 0.01 in this case. So so what happens in this to your calculators here? So what is going on in your StatCrunch is you have to go to the majority of students make mistake here is they put 1.28 because a negative 1.28 because they forgot to convert this into decimals. That is the major part that is mostly what students fall into the trap. So you go to calculator, you go to normal. The mean is 0, the standard is 1 is because it's a z-score. So z-score is always mean 0 and standard is 1. And so it's going to be less than 1%. So students do this. And that's why they get a negative 1.28. So a lot of students put B as your answer. Don't forget that this is not 0.1%. This is 10%. So you actually has to convert that to 0.001. So that is negative 3.09. So that's how you figure out question 5. Question 6 is asking for uniformly distributed. So if a question is asking for uniform distributed, you have to use a uniform calculator. So you go to the calculator and you go uniform. And the question will give us the minimum and the maximum. So the minimum is 1 or the low is 1. The upper is 10, and you need to find in between 5.5 and 5 to 7. So you had to put 5.5 and 7 here, and your answer should be 0.167. So this is what the question number 6 looks like. Question number 7, again, class, majority of you guys did the multiple choice question wrong is because you don't read the question really carefully. A lot of students on question 7, they just like, oh, this question mark is 0.3. And I got majority of students put 0.3 in the answer here, which is right if I ask for the question mark. But this question did not ask you for the question mark. This question is asking you for at least 3. See, reading questions. This is why I caught you guys a lot. That's why I'm wondering that, do you guys met my requirement? Because one of the requirements for my class beside math is reading, comprehensive. So at least 3 means you have to add 3 and 4. So that's why your answer in this case is 0.4, not 0.3. So again, these are the stuff that I want to point out to you that it's the same thing happens in your finals. Make sure you read the question carefully and see. And majority of tests, when I look at your test, you guys doesn't do any like, you know, underline circles and, you know, like me. See what I'm doing here? If I do my test, I'll be underline and circle all these questions here. Yes, Suli.
So for 6, I see that I circled the A, but you pull red. You circle B in red. I didn't understand.
I will look at your, in this case, yes, Suli.
Also, how did you find the probability for 3? Because
the total has to be 1. Your total has to be 1. In order for you to have a probability distribution, the sum of the probability has to be 1.
Has to be 1. So did you just add those 0.12 and then you did
subtract from 1.
Okay.
Yep. And the class, I think I did this before in class before you guys take the test. Question 8. We have a 5-number summary. So in order for us to figure out if you have any outliers in this case, you have to use the upper and lower fence here. This is a formula you use to figure out your outliers. You cannot use R or ROT. The reason why is because the mean and standard deviation is not given to us because R or ROT is mean plus minus 2 times standard deviation. This question only gives you mean Q1, minimum Q1, median Q3, maximum. So it does not give you any mean or standard. So you cannot use RRT. So you have to use the upper fence and lower fence, the Q3 plus 1.5 IQR and Q1 minus 1.5 IQR. First thing is find IQR. IQR is the difference of Q3 and Q1. So that is 3. So, and then when you plug this into your formula, Q3 is 18 plus 1.5 times 3, you will get 22.5. And the lower one is Q1, which is 15 minus 1.5 times IQR, which is 3, you get 10.5. So any number, if you look at your minimum, maximum, any number falls between this, no outliers. Any number falls outside this fence is outliers. And you find out that this 23 is actually above this range. So this 23 is an outlier. 13 is fall inside this range. So 13 is not an outlier. So in this case, we have an outlier and the outlier is on the high. High means on the maximum side. So that's why your answer in this case will be C because it was the maximum in this case is an outlier. Anyone have any questions with this second page here? And yes, Suli, I will look at your question 6 in this case. Anyone have any questions?
I have a question on number 8 because so you're saying that we use the first formula IQR Q3 minus Q1 equal 3 to find.
Yeah, this is Q3 and this is Q3 and this is Q1. This is IQR.
This is, I want to say this is almost my first time seeing the Q3 minus Q1 equal 3. Where's 3 coming from again?
Q3 is 18. Q1 is 15.
No, I mean 3 equal 3.
18 minus 15 is 3.
Oh, okay.
I also have a question. Can you remind me what the correct answer was for number 7?
B.
Okay.
You have to add the 0.3 and 0.1.
Okay.
Hello, Prof.
Yes, Lawrence.
That number 7 question, I got it wrong, but it was my fault. I didn't see that at least. I didn't see it. Oh my God.
And it's not yours. Everyone did not see it. So
I didn't
again,
see it. Oh my God.
It's not just you. Majority of the classroom did not see the word at least. So read. So that's the only thing I want to point out. Read the questions properly, carefully.
Okay, thank you.
Yep. The 9 and 10 is straightforward. In this case, question 9 is in this case is A. The reason why is this is not impression is not represented correctly is because you find out that this is 0.42 and this is 0.531. It looks really short. You find out if this is the Yankees in this case looks like 3 times more than the Boston Red Sox. So that's why this question 9A, the answer in this case is A. It looks 3 times more. And question 10, your answer is C. The reason why this is not correct is because it does not start at 0. So this is a lot of you get these 2 correct, which is great. Then this is the end of the multiple choice, 10 questions. So 11 is the open-ended one. Again, I'm not very picky about rounding, so I don't care if you put 2 or 3 decimal place. The 68, 95, and 99.7 is what we call as your the empirical rule. In order for you to find this number is you take the mean plus the standard deviation. So you plus one, keep on adding. So the mean is 62.48 and you add 2.39 in this case to get the rest. And then you subtract 2.39 to get the rest of this. The percentages here are fixed, 34% on this, 13.5, 2.35, and 0.15. And then you just need to add them correctly between 55.31 to 67.26. So it's between this to here. So you have, so 57.7 is 55.3 is this one. So you have to add this one, this one, this one, and this one. So you have to add all the way to 67.26. So you have to add all these 5 numbers. So if you take 2.35, 13.5, 34, and 13.5, you add them up, you should get up to be 97.35. Above 69.65, above 69.65 is only this section. So the answer in this case will be 0.15. And then if you want to do below 64.87, then you have to go below. So 64.87 is this one. So you go below. So you have to include all these 5 numbers. So it's 34 plus 34 plus 13.5 plus 2.35 and plus 0.15. So you get 84 in this case. So this is how we do the question 11 here. Anyone have any questions on this? Yes, Lawrence.
So below 64.8 is just like saying at most 64.87, right?
Below means to go down. We don't talk about at most or at least. Below means to go down.
Okay. Thank you.
Yep. We don't, in this case, we don't use the at most yet. Next, this question is telling us, anyone have any questions? Next question 12. In order for, you say 80% of the airline passengers sleep during a flight. Okay. And we pick 6 people randomly. So how do you figure out this table is you have to use a binomial calculator where n in this case is 6, p in this case is 0.8. And then you have to put px equals to 0, equals to 1, equals to 2, and those numbers will pop out, and that's how you fill in this blank. So if you use your binomial calculators and you set your n in this case is 6, you got 6 people and 80% sleeps during the flight, and you have to set this equals to 0. So this is how you do the first one. So the 0.00064 is here, and you have to keep on going up to 2, 1, 2, 3, 4, 5, 6, and this is how you get this number here. So that's the first one. Once you get this number filled in, all 0 to 6, then you can figure out the probability of at least 2. So this one, you guys read it. The word at least 2 means 2 or more. So if you take 2, 3, 4, if you take 2, 3, 4, 5, 6, and you add all this probability, you will get this number 0.9984, because that's the meaning of at least 2. That means 2 or more. Otherwise, if you do not want to add these probabilities, you can use your StatCrunch, and you just need to move it to at least 2, which is, you just need to change this to greater than or equals to 2. This is the meaning of at least 2, and you still get 0.9984. So no matter what you do, you still end up with this number. I'll close. Some of you round, some of you get 0.998 or 0.999, which is fine. You still get the if you round something, your answer will be very close to this one. To find, question C is asking to find the mean and the standard deviation. So in order for you to find the mean and standard deviation, you take n times p, which is 4.8, and the square of npq, which is 0.9798. Again, some of you put 0.98, which is fine too. And then D is asking us, is 1 a significantly low? So you can use the ROT, which majority of you use it. You take the mean and the standard deviation in this case, and you add take mean plus minus 2 times standard, you get the lower and the upper, and you find out that 1 in this case is outside this range. So in this case, 1 is a significantly low here. Majority of you do this one. Some of you want to use probability. When you use your probability, you don't look at exactly 1. When you look at your probability for this case, you actually need to use 1 or less. So you actually need to add this probability up, or you can do 1 or less using your StatCrunch, which would be 0.0016. So we are not looking at this 0.001536. We are looking at the addition of these two. And in order for you to have a significantly low, this probability has to be less than 5%, which it is. 0.0016 is less than 5%. So that's why your answer is still yes. 1 is a significantly low here because this probably is less than 5%. Anyone have any questions with this question 12 here? Anyone? Question 13, a lot of you forget the units. So don't forget the unit here is inches. So if I don't see you putting inches or like that units is inches, I will take 1 point off because that is actually part of these 12 points. So in order for you to find all this, you have to first go to the foot and height. So you have to go into the StatCrunch and get the data set. And the foot and height is the second one. And we are concentrating on the foot length, which is this one. And how do we find the mean and everything is we will use stats, summary stats columns, and we are concentrate on foot length. And we're gonna do all of this. So I do Control A. So Control A means everything. And this question wants us to find percentile. So you actually have to type in the percentile here, which is 48, because the question here asking for 48 percentile, and you hit compute. So this table will give you all the informations here. So the mean in this case is 25.68. The median is 25.5. The mode, which is at the end here, 23.8. Mid-range is the one that a lot of students make mistake, is mean plus max over 2. A lot of people subtract them divided by 2. That is not your mid-range. So you have to take the minimum and maximum, which is 21.9 and 29.2, add them up and divide it by 2. Your range is 7.3. Your standard deviation is on the other side, 1.98. Your variance is 3.908. Q1 and Q3 is here, 23.95 and 27.15. IQR is 3.2, means the difference between Q3 and Q1. And then the 48 percentile, if you type 48 in the percentile, then it came up to be 25.4. So this is how you do your summary statistics here. And then in order for you to do a box plot, you need to go to the graph and box plot, and you select foot length. And if you want to draw the box horizontally, which I prefer you to do it, and then you hit compute, and you will get yourself this box plot. So you just copy down, and if you hover your mouse over here, they will give you the 5-number summary, which is the last 5 numbers, the lower, the Q1, the lowest and minimum, the Q1, the median, the Q3, and your upper. So that is your 5-number summary. How do you interpret this box plot? You need to do CVDO. Now, since there is no outliers in this case, you have to report the mean and the standard deviation.
I have a question about that interpreting the box plot. Because you know how you told us to hover like over, not that part, like to the left and to the right where the lines are, and then it would
if there's only outliers that exist.
So when I did that, a whole bunch of
Yes, there's
yeah.
no outliers here. You only hover around when you have outliers. Remember when we did a question about the
Yeah,
Oscar one? Remember the
Yup,
Oscar
and
one?
that's why when I highlighted it and it popped up, I was like,
Oh yes, if you had remember we did the actress one,
yeah,
because these are the outliers.
I
That's why we highlight the outliers.
yep, I realized that now.
But we don't have an outlier in this case, so you don't need to
Okay.
highlight anything. Yes.
Okay. Dang it. Okay.
So
No
I-
outliers. Yeah,
Hmm.
if you highlight, yes, they will give you tons of dots.
Yeah.
You don't do that. You only
Right.
highlight when there's only outliers that exist.
so
When the dots popped up, I was like, oh, that's outliers because there's a whole bunch of them.
Oh, those are all numbers inside,
I know. I didn't even.
not outliers here.
I didn't even. Yeah, it didn't
Okay.
even cross my mind. Okay.
And this is considered symmetrical. The D is called distribution. Is some of you say not skew, which is fine. I still take it. Symmetrical. So
Wait, why isn't it evenly distributed when it looks like? I mean, when you say symmetrical, they're basically evenly distributed, then, isn't it?
Yeah.
Because it's the same.
mhm. Yeah, it looks like it. Do
I
you really
thought
need to?
symmetrical was like bell shape. I thought that was
Symmetry doesn't mean bell shape. Symmetry means the left and the right is the same.
Okay, never mind. I got it right.
Okay,
I
this
thought
is
you
symmetry.
marked it off. That's why I was like, why did I get it wrong? Never mind. My bad.
Right.
Thank you.
Don't forget, check mark is correct.
Yeah.
Questions, anyone? Let me finish this one first before we continue. So the last one is you need to find the z-score. So the smell in this case is 31 inches. So in order for you to find the z-score, you have to take the value, which is 31, minus the mean. The mean is the one that you found, 25.68, over by the standard deviation, also you found early on here, which is 1.977. Your z-score is 2.671. And then the question is asking, is this significantly low, high, or no significant? Since the z-score is above 2, this is significantly high. So some students did not find the z-score. They use the ROT. You can still do that. You will lose a point because the z-score is what I want you to find. Okay. So, but you will still get the point here. You didn't lose all the points. The answer is significantly high. So now the questions you guys have for this number 13. (14) is this is talking about the blood pressure for the females. These are the units. It's been sorted, means it's been nicely done from low to high, so you do not need to count it. So the question here is asking you to begin with a class limit of 40 with the class width of 10. So how do you build frequency distribution here? Is you add 40 plus 10 is 50. You go down. So 40, 50, 60, 70, 80, 90. Now I got students do 100, 110, continue doing it. Please don't do it because your maximum is 94. So you stop at 99 here. You don't continue doing this. And the upper limit in this case is 49, 59, 69. So make sure it's a little one shy away from your other class. And then you just find the count of frequency. So there's 1 in 40 to 49, 0 on the next one. 60 to 69, there are like 7, just count them. Okay, and this is what you get for the frequency distribution. To find your class midpoints, you need to take the lower and the upper and then add it up, divide by 2. So 40 plus 49 divided by 2, you get 44.5. You do the same thing for the 50 to 59, 60 to 69, all the way to 99.9. So this is all your class midpoints. For your class boundaries, you will be taking the upper of the first one. So this is, you take this upper and you with the lower, So you take these two and you add them up and divide it by 2. So if you take 49 plus 50 divided by 2, you will get 49.5. And then the next one is you add 59 to 60, the upper and the lower of this, and divide it by 2, and you will get yourself 59.5. So you will get this here. So however, you need to figure out that there is an additional one that is above, so that is between 40 to 39. So that's why you get the 39.5. And there is one additional down here between 99 to 100, you got 99.5. Another meaning is if you got 1, 2, 3, 4, 5, you got 6 classes, you should have 7 boundaries. Okay, so make sure you guys know that is extra 1 more. So this is how you figure out your class boundaries. In order for you to find the relative frequency distribution is to take all this frequency and then you divide it by the total. Make sure that these are your contacts. So some of you who did not give me the context in this case is the numbers that you have here. So these are your contacts, which is exactly the same as this for the relative frequency. So you take 1 over 24 times 100, which is 4.2%. 0 will be 0. 7 over 24 times 100 is 29.2. So these are how you figure out your relative frequency. We still use the blood pressure from the one that you did in A. For cumulative, you take the frequency and you add them. So the first one is 1. The second one is still 1 because 1 plus 0 is 1. The next one is 1 plus 0 plus 7, which is 8. And then you keep on adding it, 16, 22, and 24. And again, the context for this is not the same as here because it should be from 40 to 49, and then 40 to 59, and 40 to 69, and so on. Or you can use less than or equals to 49, 59, like what I did here. So there are a couple of ways to write it down. So this is your context for this.
But it says, your direction says construct the relative frequency distribution and the cumulative distribution. It doesn't say, that corresponds to the frequency distribution in part A. So I assumed, okay, well, I already completed part A, and C just says, I just need to do relative and cumulative. And so that's the only reason, that's the reason why I didn't put A down there too. I just did the relative and cumulative.
Again, numbers without context are meaningless. So if you just give me these numbers, what does this number means?
But it says to the frequency distribution in part A.
And the same thing with cumulative. Even the cumulative, you cannot use this context because it's not the same. Did I teach you this? Do I write? Okay, class, I'm going to tell to you guys, when I teach you this section, do I teach it the way that Casey say or the way that I did here?
Well, when you were teaching us, it was one long, it's like the multiple boxes that they were all together. I didn't realize that you were going to split them up into like multiple parts like this, where we had the I don't know, it's my fault because I misunderstood. I just thought, oh, he just wants the relative frequency and the cumulative frequency.
No,
and
I
he's creating
thought
it
he
in part
meant
A.
the same thing too. I thought he just
Yeah.
meant 2 things. I feel like it would be helpful if you put in the context for us, and then we fill in.
No, I would not. If I put the context for you, then you do not need to figure
So
this
do
out.
you mean like 40 to 49? Is that a context to you? Because I thought
Yes,
you
this
meant-
is the context
Oh,
I'm talking
okay.
about.
I
This
thought
is
you
a
mean like
context.
blood pressure, percentage. Those
No,
are-
this is the context.
Oh, okay.
These are the numbers. These are the contexts that you're missing.
I didn't understand context. When
Look at your homework. It's very easy. Look at your homework. Do they just give you that number, or do they have a context next to it?
No, I get it. It's all together. It's like I said, I just misread it where it said, hey, I just need the relative frequency distribution and the cumulative. And then where it says, frequency distribution in part A, and I automatically assume, well, we already completed part A, so I'm just going to correlate it to, here's the frequency, here's the relative frequency.
I know what you mean, Casey.
correlating
You know
that.
what
Yeah.
Casey.
Yeah,
know
that's
what
my
you mean.
fault. Yeah.
But still, if you want to correlate with this, then your cumulative is still going to be wrong. It's not correlated
Yeah.
with that.
No, I did it correctly, even though I didn't put like, like when I calculate it out, the answer itself is correct. It's just I didn't put like the 40, to the 49. I just
Mhm.
automatically did it.
And let's do the last one before we come. Is this normally distributed? How do we figure out it's normally distributed? You look at your frequency, and this frequency goes from low to high to low, and it's kind of symmetrical. So in this case, this is a normal distributed. So I just want to say that, class, is yes, every time when you build a frequency distribution, relative, cumulative frequency, you need to have something that correspond to it. You cannot just have it this by itself.
Yeah.
Okay, because then it will not.
Prof, I didn't know that.
And
too.
if
I
you
didn't know
do that and don't say I'm your teacher, because everyone look at you like, what is these numbers? Yes, Lawrence?
I didn't know that too. I didn't know that.
Because usually if you guys don't show me all these numbers, and if you present this to and if you just do this and present it to your boss will ask him, what is this number means? You know what I'm saying? So that's the reason I am great. I'm teaching you guys so that people did not take stats class understand what is going on.
Yeah.
So I know what's going on. I totally get what you mean. So make sure you guys know that not everyone takes stats class. So make sure you guys know this. All right, last one, question 15. This is talking about the airlines. The weights for men is 172 pounds. Standard deviation is 29 pounds. You need to draw the sketch. So make sure you have the sketch. This is the sketch I'm talking about. And you need to round in 4 decimal place. So the first question is asking for 20 adults. Since 20 adults is given to us, so CLT is used here. So find the probability that this is greater than 195. So the mean is 172. The standard error in this case is 29 over by square root of 20. And 195 and above means you shade it to the right. So for your normal, in order for you to do this in your StatCrunch, you have to use back your normal calculator. So you will use the mean is given as by, it's my norm, there you go. The mean in this case is 172. The standard deviation in this case is, I would not want you guys to use your calculator to type to figure out what is this value. I want you to type out 29 over by square root of 20. And you need this over by 195. So this is your answer. In 4 decimals place is 0.0002. Okay, so this is your question A. Question B, if you read question B, we don't use 20 adults, we use 213 adults because that is the plane usually sit that many people in the plane. This is also CLT because we use this many people. And now everyone has a 20-pound carry-on. So when you have a 20-pound carry-on, your mean will become 192, not 72, because it's been at 20 pounds. 172 plus 20 is 192. And your standard error is not 29 over root 20 because we are not talking about 20 people. We're talking about 213 people. So in this case, you also use your normal calculator, but your mean in this case is going to be 192. And your standard deviation in this case is 213. And we are still looking for greater than 195 pounds. So your answer in this case is 0.0656. So this is how we calculate question number 15, which is the last question here. Anyone have any questions on this? Anyone have any questions as general as your tests? Besides Suli on question 6, I will check it and I will definitely, if I make a mistake, I will definitely give you back the points. Anyone? have any? Now, if you do, please talk to me after class, because I will, and help me to add the points. So if you see me putting a -2 here and then -3, whatever, on all the pages on the side corner here, add them up and then take away from, let's say I put like something like -15, then your point example, then you get 45, So please double check my arithmetic work, because sometimes I do add wrongly. And if I do, send me an email and I will definitely will go over it. I will look at it because I still have the test with me.
Hello, Prof.
Lawrence?
What is the mean score for the exam?
I do not know, but I will let me calculate that, because I did not write it down, but I can write them those. Yeah, let me calculate it. So I want you to do some work and then I can calculate some stuff. Yeah.
Okay.
Because I was
thank you.
thinking about doing that. Yeah, I will do that for you guys. Just I have to let you guys do some work first. All right. I will do the mean and everything. So I want you guys, this is chapter 7.1. So I want you guys to continue working on this 7.1. So do not forget that, read the question really carefully and figure out what you need. First thing is for this this section 7.1, you need to go to stat, proportion stat, one sample with summary, and you need to know what is your X. X in this case is the number of success. N in this case is the number of observations. So I want you guys to read question 3. And I want you guys to figure out what is X in this case. And what is N in this case. And what is the confidence level in this case. Go ahead and try to do question 3. You guys got these notes, right? And I need to do some work here. So read that questions and figure it out. I'm going to stop sharing here, and because I need to do some, pull up your information. So try to do the work here while I'm calculating your mean and stuff. Someone asked me that. Make sure you guys read the question carefully. Same thing in your finals. Especially the multiple choice one, they're really tricky.
Hello, bro. Hello.
Yep, Lawrence.
Sorry, can I see the question again? What? Can I see the question again?
I cannot hear you.
Can I see the question?
Anyone know how to find X here? Anyone? What's the X in this case?
X is 701.4.
How you get 701.4?
That's 70% of 1002.
So you take 1002 times what?
Times 70.
0.7. Yep. You get 701.4, right?
Yep.
Can you have 701.4 people?
Yeah, sure, we can.
You can. So should I take
Yeah.
a store and start sorting people up to 0.4?
Yeah, because the number of survey people is 1002, right?
These are the people who vote. So can you have a 0.4 people?
No.
So what you do?
701.
Okay, so this is one thing that please don't put 701.4 in your StatCrunch. They will give you error because of the decimals. And 0.4 is small enough, so you cannot round up. And what is your n in this case?
1002.
And the confidence level?
61%.
No. 0.98. This is found in part A, 98% confidence interval. So so put it in your StatCrunch. What you guys get when you put this in your StatCrunch? You go to stat, proportion stats, one sample with summary. Number of success is what?
Huh?
701 is a number of success.
Yeah.
Lawrence, I might need to mute you. And
I'm sorry, I'm at work. My boss
is
is around.
your observation. And confidence level in this case is 0.98. And you hit compute. So this is your results, which is the lower and upper. So your part A in this case, your confidence interval in this case is 0.6656. If I put in 3 decimal place, 0.733. So this is how you do your 98% confidence interval. I'll just put it at 98% here. Questions? Question B. Oh, by the way, in your test, beside writing this, you have to tell me where do you go. So you go to where you need to enter. So this is important. So when you guys do this in my test, make sure you put this in your test. X equals to what, N equals to what, confidence equals what, and then you give me the answer. If you do not give me this, you will lose 1 point automatically. I don't care if you get it right. The confidence interval is right or wrong. So make sure you guys give me X, N, or confidence level, or tell me what do you enter, or in other words, tell me what you enter here, because I do not know what you enter in your, when you do in your test. So make sure you have to tell me what do you put in there, 701, 1002, and 0.98. Okay. B, are the survey consistent with 61%? So this is something like our ROT. Is 61% in or outside this range?
Outside.
So 61 is outside. So is this consistent? The answer will be no. This is not consistent because 0.61, which is 61%, is outside the CI. So we don't use the word range or ROT anymore. We use the we use the letter CI or the word confidence interval. Don't forget, CI stands for confidence interval. You guys are right here with this question 3. Right. Before we go on to number 4, I did have your test with you, with me.
Wait, I
Yep.
have a question. So I was trying to figure out where I was supposed to go to figure this, because I figured out the X and I figured out the N and the confidence level, but I couldn't figure out where I was supposed to put this in stat because mine didn't have that.
Stats, proportion stat.
You know
one
what?
sample.
Just leave it outside. I'll come and pick them up. now.
Lawrence, stat, proportion stat, one sample with some. I think I
And it's
email you
summary?
a
Okay.
the summary. I think I email you a note, right, Casey?
I don't know. I have to look.
Yep. Sorry, I know
Okay.
I give you the wrong one. So
Okay.
this is the one that you have to go.
One sample summary. Okay. Thank you.
Right. Next is I got your test score. So this is your test score. So I'm going to put this in my summary stats and see what is your everything. So the mean for this this is out of 60. Don't forget, it's not out of 100. So the mean for this task is 44.43. The standard deviation is 6.48, somewhere around that. Okay. The IQR is 11. The minimum is 16. The maximum is 54. Again, this is out of 60. Don't forget, this is the rest. The mode is 53. So this is your summary statistic. For this is your test. Test 1, a midterm. And then we go to your box plot. We'll draw a box plot for this case. So this is your box plot. So there is an outlier, which is 16. So that's one outlier in this case. So this is pretty much skewed to your left. So majority of you is in this range. Again, the test is out of 60. So
Can I ask why there's an outlier?
Because someone did bad.
Oh,
One student scored 16, that's it. Straightforward. Okay, so that means that student who scored 16 is out. That's
okay.
the meaning of it.
Sorry, I thought it was a mistake or something. I was confused.
No, that means one student did, which is yep. Anyway, so so this is the stuff that you learn in my class. So pretty much skew. So the median is 46. So I recommend median. So if I take 46 out of 60, because the reason why I take 46 is because it has outliers. It's around 77%. 76% is your average. So that is the reason why I take median here is because it has an outlier. Okay. All right. Now I can open a new one. Okay, next we're gonna talk about question 4. Now question 4 is where you have to refer to M&M. I'm gonna point out this is so you have to go into your StatCruncher and you have to look at your M&M. So not food, not Oscar. So there's one called M&M, the weight, M&M weight. So if you look at your data files, it's called M&M weight. So this is the M&M weights data files. What is this? This is where 100 M&Ms that the author opened up. You guys got plain M&Ms, right? Plain M&Ms that you buy in store. So what did the author do is he opened up the bag and then randomly picked 100 M&Ms out, and he measured how heavy is that. So let's say he go and grab one first, and the first M&M is, let's say, is red color, and he'll put in the weight, and though it is 0.751 gram. And then he put in his mouth, and then take another M&Ms, and let's say that M&Ms is orange, and he put in the weight, the scales, and the weight came out to be 0.735 grams. And then he put them out, and then he keep on doing this for 100 times. And this is the result he got. Okay, so this is the result he got. So the question is asking us is, based on this M&M OK file here, there are 100 M&Ms, and the Mars company, which is the candy bar, says that 16% of the M&Ms is green color. 16% is green. This is based on the Mars candy. This 16% is your population proportion. Okay, that is 16%. So you need to find the 95% confidence interval to estimate the percentage green M&M. So as usual, you have to tell me what is your X, what is your N, and what is your confidence level. Now we know the confidence level in this case is 95% because 0.95 because the question asks you for 95. We know N because anyone know what's N in this case? How many candies do we have?
100.
100. So that means if you look at your data here, there are 100 candies here. So my question to you is, what is X in this case?
2.56.
Hmm?
2.56.
Why 2.56?
It's 100 times 0.16 equals 2.56.
Where you get 0.16? Oh, no. This is population proportion.
Mm,
This is not, so do not take 0.16 times 100. That's not right, because this 16% is from the population. This 70% comes, if you look at question 3, the 70% comes from the survey. So this is your sample proportion. And yes, you can do it this way on number 3, but on question 4, you cannot do it the way that we did in question 3, because this 16% is the population proportion. So do not take 0.16 times 100. This is wrong in this case.
so it would be, what's 100 minus 16% then?
Nope. And don't forget, this has to become from your sample. And that sample is in your,
Oh, it's in the,
because
okay.
this is 100, right? It should become in your sample. So don't forget,
Okay.
everything that you put here has to be from your sample. So can you tell me how many green M&Ms do we have in this sample? This is green, right?
Yeah, there's 19 of them.
So there are 19. So X in this case will be 19. And this is coming from the sample that is green M&M.
So if it's 19, are we still doing, okay, so it's just straight up 19 then? It's not like a percentage?
No.
Okay,
Because this is numbers here, not percent.
okay. And what did you say it was? It was, you said it wasn't population or proportion?
It's not, yeah, this is a population proportion here. The
Okay,
16% is a population proportion. So we don't use that.
okay. Proportion.
Okay. We will use this to test and see if this is the correct. We always use a sample to predict the population.
Okay,
Okay. So in this case, we will go to, again, stats, proportion stats, one sample with summary. So the number of success in this case is 19, because we got 19 green M&Ms. We got 100 observation because there are 100 candies here. And we are using a 95% confidence interval. And you compute this. So your answer in this case will be these numbers. So the confidence interval in this case, the 95% confidence interval, is going to be between 0.113 to 0.267. Now we will use this 16%. We will use this 16% because the question is asking is, what can you conclude about this claim of 16%? Is this 16% in or outside this range? This in the interval. So is a conclusion, is a claim valid or invalid?
Would it be valid?
So the claim is valid. You can say valid, you can say correct, you can say true, or you can say is right, all the positive ones, because 16% is inside the confidence interval. Okay, so what we do is that the company says it should be 16% green M&Ms. So what do I do is I open a bag of M&Ms and figure out, is that really 16% is green? And based on a 95% confidence interval, yes, 16% is true because it's inside this range. Okay, and yes, you can find this in the Mars company. You can type in, you can search for Mars company and figure out how many green or blue or yellow M&Ms they produce in this whole week, and they will tell you how many percent came out. And you can then go to the store and buy M&Ms and count them and then see if it's really matched with this 16%. Now, if you look carefully, this is 19% is green from the sample, but we don't look at 19% because there is some margin of error. Okay, so this is how we're answering this question. This homework is due on Wednesday, not today, but the following Wednesday, the 27th. So this homework is due on Wednesday, the 27th. Do not forget, you guys have no class on Monday. And the next Wednesday, the class is still going to be Zoom. Okay, so we have 2 weeks of Zoom on Wednesday, this week and next Wednesday. Next, yes, Amin.
My connection just cut out. Is class about to be done?
A little bit more, like maybe like 10, 15 minutes.
Okay. Just wondering.
30 minutes.
I was kind of confused.
It'll be done at 6. Same class, same time as the class time.
Oh, okay. Perfect.
So this is what we learned in this section 7.1 is what we call as population proportion. So this is for categorical type variables. So that's the reason why when you look at this type of questions, they're asking for colors like green, blue, yellow. They are categorical. This one, if you look at question 3, they're asking for either you vote for this president election or you did not vote for it. So yes or no. This is also categorical variables. If you look at the other one, this is talking about the lawsuits being dropped or not, dropped, guilty or not guilty. Again, it is categorical, either yes or no. Okay, so if majority of this type of questions in 7.1, they are all proportion, categorical variables. But when you look at 7.2, this is mean. This is all talking about mean. So when we talk about mean here, we don't talk about categorical variables. We talk about quantitative variables. For example, we can talk about your test score. So your test score is quantitative variable in this case. Yes, go ahead and take attendance. Some of you did talk about attendance here, so go ahead and put down your chat room for attendance here. So so what happens in the quantitative variables? We don't talk about proportion, percentage, probability, they're all linked together. Now we talk about mean. Okay, so if you remember the best point estimate for the proportion, so what part B, what is the best point estimate? The best point estimate is the sample proportion p hat. So for this case, what is the best point estimate for the population proportion? The best point estimate for the population proportion in this case is the sample mean. Okay, so so in order for us to figure out what is the best point estimate for the population mean, mu is the symbol for population mean, and the best point estimate in this case is sample mean x bar. So how do you find your sample mean? if the question provide you a sample mean, you use that. If a question provide you data, like what we did on, like this, they give you data, then you just use the summary stats. Remember we did it, you go to stats, summary stats column, and then you pick, let's say, rate, and you find the mean. So this is the sample mean in this case. So it depends on the questions, what they provided to us. So last time we used a Z distribution or normal distribution to do 7.1. In 7.2, we will be talking about student T distribution. So this is a new distribution. So it's not gonna be normal distribution anymore. So it's gonna be a student T distribution. So we're not gonna use normal. So normal is just for proportion. So what is a student T distribution? A student T distribution is also kind of like a normal distribution, but it depends on the degree of freedoms. So this is very important. So the T distribution depends on degree of freedom, and the degree of freedom for a T distribution is n minus 1. N in this case is your sample size. What is a degree of freedom? Degree of freedom is the restrictions that you can be imposed to your data value. Now, and another words for degree of freedom is how many students do we need to know in order for you to figure out everyone. Let's say that I give a test, right? And let's say that if one of you did not write your name in your test, do you think I can figure out who is this student is? If everyone wrote the test except one student didn't write the test, a name, do I know who is that test belong? Sure, because I keep putting in your gradebook, right? And the one that is missing, that would be you, right? That would be the person that is did not put the name. How about if two of you didn't write your name in your test? Let's say David and Ben. Do I know who is David and who is? I do not know who is it because two of you, and I put in your grade score and I found out David and Ben are two missing test score. So I cannot figure out who is who until I go to David. Hey, David, is this your test? Which one is your test, right? Which one is your handwriting, right? So that is the one that, so this is called a degree of freedom, means that if I give a test, if one of you doesn't write your name, that means if I give 15 students, if one of you, 15 minus 1, 14, if I know 14 of you wrote your name and one did not write your name, oh yeah, I can figure out who is that person. So that's the reason why the degree of freedom in this case is n minus 1, because if only one of you did not write anything or did not do anything, I can still figure out who is this person is. So that's the meaning of the word degree of freedom. Okay. What is a T distribution looks like? So I will draw it out to you guys. So this is what a T distribution looks like. A T distribution, it looks like a normal distribution, but it has depends on degree of freedom. Okay, so if your degree of freedom is small, let's say is 5, that means you only got 6 students. Okay, so 6 n is 6. What happens to your T distribution here is you will get your n here, your tail end here is going to be a bit fatter, a bit more heavier, and the middle part is a bit more shorter. Okay, so this is what happens when your degree of freedom, when you have a small sample size, your n is 6. Okay, what happens if you increase your n to become 11? I use green. That means your degree of freedom in this case will be 10. Because 11 minus 1 is 10. Then your tail is getting thinner and your point n is getting taller. Oops, sorry. So this is what happened, the green one. So this is what happens when your degree of freedom is 10 or your n is 11. Now, what happens if I keep on increasing your n from small to big? So now my n is 31, where your degree of freedom is 30. So you notice that this is getting thinner on the tail end, and this will get taller. Okay. And what happens if n in this case is infinity? That means big, very large. We call it large. Then your t distribution will look something like this. And when n is getting large, your t is get closer, will become z. Your t distribution will become z. Now, remember the mean. So when you do the z, the mean here in this case is still 0. Remember, in z is 0. However, your standard deviation that you do here is greater than 1. So for t distribution, your standard deviation is greater than 1. Out of z, when you talk about z in this case, the mean is 0 and the standard deviation is exactly 1, right? But for a t distribution, your mean is still 0, but your standard deviation is above 1. So it can be 1 point something, 2 point something, 3, 4, 5, but cannot be equal to 1. Okay, it still has a normal shape and it still have symmetrical. And so when you find, remember, I want you to find what is the percentages that is for above 1. So you go draw 1 here, right? Let's say 1 is here. And above, you shade to the right, right? So if you have a small sample size, look at this. Your probability is a lot. But if your sample size increased to 11, look at your probability. It's even what is smaller. You see that? And when you increase the red one, if your sample size is big, your probability is even smaller. And then the more what happened is you find out that this probability depends on your degree of freedom. The higher the degree of freedom, the bigger the tail end here. Your probability will be higher compared to degree of freedom of 10, 30, and so on. Okay. The reason why that we can use a small sample size here is because we don't have that many people. For example, our classroom, we only got 15 students in our class. And if you remember central limit theorem says that your sample size has to be what? More than 30. But our classroom only have 16 students, right? Or 15 actually. I cannot make it 30. You know what I'm saying? So there is one person saying that, you know what, I only got these 15 students in my class. How can I get 30 students or 31 students? I cannot simply add more students in there. So what happened is he designed this t distribution to figure out that, you know what, I can have a small sample size, but what happened is that my tail will get bigger, means my probability will be a bit more higher compared to a smaller sample size. So that is what happens when we begin to use the t distribution, which is a very famous distribution that people use. Okay, and so what happened is that this is all we just talk about over here. So the first thing I just point out to you, t distribution is different, depends on the sample size. So each sample size has its own normal curve. It's symmetrical, bell-shaped. The mean is 0. The standard deviation is greater than 1. And as your sample size get larger, your t distribution will get closer to the norm, the z, the standard normal. So this is what we mentioned early on this picture. As long if your n is getting bigger, your t will be getting closer and closer to z. And yes, if you go to your textbook on page 319, they got a nicer picture in this case. Okay. So requirements. The requirements, we cut it really two. One is simple random sample. One, the second requirement is normal distribution or your sample size is less than 30. Okay. Now this requirement is loose. Loose means that you can, you can change if you don't have 30 people. So that means if you have a smaller sample size, okay, you can still use this distribution as long as it doesn't show any outliers. Yes, Suli?
Oh, I didn't have it first.
So, so these are the two requirements that we have. It is simple random sample. It is normally distributed, or the sample size is greater than 30, or both. So you can be both of them. But this is loose. Loose means that you do not need to fulfill this. That means if you have a smaller sample size, what you need to do is you need to check for outliers. If outliers exist, no good. Okay. So so another meaning for this number 2 here is if you have small n, small sample size, and no outliers, number 2 is fulfilled. Okay, so so this is the loose requirement. So if you have a small sample size and you figure out that there is no outliers based on this small sample size, then we fulfill number 2. If there is outliers, then you cannot. Okay, so the question is if there are outliers, number two means this number. This is the second condition. Will be rejected. Okay. So make sure you guys understand this. So this is only happens when your n is small. Okay. So what do we do with? We're gonna do some rotation here. So mu in this case is the population mean. Okay, we call this as your population mean. S is your population standard deviation. Population sample, sorry. This is called a sample standard deviation. X bar is called a sample mean. N is called the sample size or number of observation, same thing. E in this case is called margin of error. So in order for you to find the margin of error, it's the same thing you did on the previous section. You take the mean at the uppercase minus the lowercase divided by 2. T alpha over 2 is called the critical value. Okay, so T alpha over 2 is called a critical value. Now, if you compare this with 7.1, the previous section, the critical value that you have over there is not T alpha over 2, is Z alpha over 2. See that? Okay. And the reason why we use Z alpha over 2 in this section is because this is for standard normal. It's normal distribution, 0, 1. And so we use Z. But for this section 7.2, we will use T, and T stands for T alpha over 2. This is what happens when I don't want it. So we use T alpha over 2 in this case. Okay, and how do you find the critical value for T alpha over 2? Is you go to stat calculator T. So you do the T calculator here. They ask you for the degree of freedom, and then X greater than or equals to blank. The blank, make sure you blank it up. And then you got that alpha over by 2 on the other side. And again, what is alpha in this case? Alpha is the significant level, or the type, we call it the error, type 1 error. And usually is given to us by the confidence level. So remember that you have a 95% confidence level. So what will be your alpha in this case if I ask for a 95% confidence level? If it's a 95%, what is your alpha in this case?
0.95.
No, it's the opposite of 95%, which is
5.
0.05. It's 5%. Yep.
Yeah, 0.05.
0.05. So make sure you know alpha is the error, means that 95 is confidence. So you got 5% error. That is your alpha. And that alpha goes into here. Okay. So we can also do a critical value here. So I showed you what does that mean. So critical value. So remember last time we find a 95%. This is what we call as your critical value. Okay. And your confidence interval here is going to be from this to this, the lower and upper. So that's why you got that 5%, the difference, we call it alpha. And this 5% has to be shared among the low and the high. So that's why I take the alpha over 2, because I have to split this into 2. Okay. So how do you find this critical value? It depends on your degree of freedom. So let's say that you got 20 students. So my degree of freedom is 19. So what you need to do in order for you to find this is you go to T calculator. So in your StatCrunch, you go to stats calculators T. Last time we do what? Binomial, we do normal, right? This time we do T. And they will ask you for the degree of freedom. And since I got 20 students, the degree of freedom is 19. And you set this always greater than. And you, since the alpha in this case is 5%, so we divide this by 2. So this is how you find your critical value in this case. So this number is 2.093. And then don't forget, the other side is exactly the same, but you use a negative. So this is a T distribution. So so make sure you blank this follow-up. Okay, put in these two numbers. This is the degree of freedom, and this is the alpha over 2 here. And this is in your notes, except for Casey and Skylar. You don't have this one, right? Sorry, you have to maybe change. If you got the new email, that's a new one. Or if you see in person, I will give you the new one. Okay. You do not need to use this formula to find your critical your confidence interval. So you got 2 types. So again, Casey and Skylar, you might have to change it, because that is for those to find your using StatCrunch, you go to T-stats 1 sample, either with that data or with summary. So either one of this. So make sure this is very important. Okay. So these are the way that how do you find your confidence interval. You go to stat, t-stats, one sample with data. So if you want to go with data means that you import the data file.
Hey, David, I have a quick question for you.
Mhm.
So I don't know if you can see it. All of this is gone then?
Gone, yeah.
Okay.
Mhm. Yep, all is gone and change it into this one. So you with data means you got data files. So that means that if I call you to go to like the Bears, the Oscar, the height and weight, or you import your data from your homework, you know, you guys do your homework, you import it, then we go through with data. If the question provide us summary statistics, means the question give us the mean, the sample solution, the sample size, and they provide all those. Then you go what stat, t-stats, one sample with summary. So make sure you guys know which one to pick. You guys with me here? So data means you got data or it is imported from your homework. Summary means the question provide you the sample mean, the sample standard deviation, the sample size, and so on. Okay. For example, you can look at the questions. So if you look at question number 2 here, refer to chips. That means chips is your data file. So what do you think about this question 2? Are we using with data or with summary?
Want to be data?
Yep. So this one is going to be with data because it's under chips.
Mhm.
And what happens for question 3? If I say you got a random sample with birth weight of 186 babies with this many grams, that mean, and essentially is this many grams. So what do you think about this one? Is that with data or is that with summary?
Sample, because it's already giving you that information.
So this will be with summary. Okay, because they're giving you all the informations. So so this is how you differentiate between with data and with summary. So let me show it to you in the R. So you go to stats, t-stats, one sample, sorry, stats, t-stats, sorry, stats, t-stats, one sample, and then with data or with summary. So either the first two, so you pick it. So when you say with data, they will tell you which column you pick for data because your data will be imported or you have to type it into your columns here. And then you make sure you put in the confidence interval. Okay. So that is where you do with data. Okay. If it's a with summary, I will let you look. It will tell you to enter the numbers in there because with summary, they will give you the mean, the sample selection, the sample size. You have to enter it. And then make sure you click on the confidence interval and you compute it. So that is the difference between with summary and with data. Okay. Again, how do we write your answers in your confidence interval? There are 3 ways. You can write it in the lower and upper. This is usually what your StatCrunch provide to you. You can also do it as X bar plus minus E, or you can write it down as this less than mu less than that. So you just take your lower is less than your mu is less than your upper. So you can write in this way. And if you want to write in the X bar plus minus E, you can still use the same formula, which is you can find the X bar by taking the addition those two and divide it by 2. And you can also find the margin of error by subtracting those two upper and lower and divide by 2. So they are very similar to 7.1 that you did last time, except this times we don't use P, which is proportion, or P hat. We use X bar for mean. Interpreting is also the same thing. We are 95% or 99%. The confidence interval from the interval from this to this actually does contain the true population mean. Again, you have the word mean in here. So last time we used population proportion for last section. So this time we do population mean. Usually you got this lower and upper from your StatCrunch, but don't forget you need to put unit now. Okay, last time in the proportion, we don't have unit. This time the mean, it has unit like test score, height, inches, degree Fahrenheit, centimeter, grams, all those things. So make sure you have units in it. So don't just copy and paste from your StatCrunch. So, oh yeah, this one came up to be, I can do one for you here. I can do like T-stats, one sample with data. Let's do the rate one. We do a 95%. So this is the confidence interval that we have. And don't forget, this is all measured in grams. I will tell you in the questions. So make sure you put grams on it. It has a unit on it. Okay. And the last things I'm going to talk about here is the wrong way to do it. So do not use the word chance. Do not use the word sample. Make sure that you have to use the word. These are the keywords I'm looking for. Confident. Population mean, this is also last time proportion, this one is me, and contains the true value. True value is important. So these are the few keywords I'm looking for when you do your interpreting. Same thing in your homework and your test. So if you don't use the word chance, don't use the word sample, make sure everything is in population. Okay. So this is 7.2, the notes. So when you come back next Wednesday, we will do some examples here. Okay, so so for Casey, will you come to school, or you're not going to go to come? Will you be in school or no? You will be. You got muted. I cannot
Yes.
hear you.
Yep, sorry. Yeah,
You're
Wednesdays
fine.
I'll come. Yeah.
Yep. So can you hold on to that, or do you want to get a new one?
I'll hold on to this one, and then I can, you said that you sent it to me, so what I can do is I can print it out.
Or if you want, you can go to D2R and get it, because the D2R has all my notes there.
Okay. Oh, yeah, I'll do
Yep.
that. Okay.
So I will show it to you later on. So I can show it to you. Yep, later on I'll show it to you. Anyone have any questions? I'm going to stop sharing here and start recording. And Casey, just wait